So the fourth step in the cleaning and disinfection process is the step of drying. So in an ideal world, you'd want to dry the premises completely before applying the disinfectant. And there's a couple of reasons for this. The first one is logical. If you have residual water on the surfaces, that will act as a diluent when you apply the disinfectant. In other words, the concentration of disinfectant that you would expect will be slightly lower if you have presence of substantial water on the surfaces. There's a second aspect to this, and it has to do with potential incompatibility between a certain type of detergent and a certain type of disinfectant if the detergent hasn't been removed and rinsed properly. So for example, a very common type of detergent used today in farming operations is based on the use of anionic detergents. Anionic detergents or anionic surfactants are molecules that have a negatively charged head or a negatively charged part. Now, on the other hand, one of the more prevalent types of disinfectants that are used today are quaternary ammonium compounds, or quats for short. Quats are positively charged molecules. So what happens when you have a positively charged molecule come together with a negatively charged molecule, they come together through electrostatic interaction, and the end result is that they neutralize each other. So in other words, now the anionic surfactant or the anionic detergent will not be able to clean anything because it's tied up with a quat molecule. But more importantly, the quat molecule, which is supposed to disinfect, will not be able to disinfect anything, will not be able to kill anything because it's tied up with a detergent molecule. So if we used an anionic detergent in our soaking step and we didn't rinse properly and there's residue of that detergent, and then we're disinfecting with a quat, you might see some of that inactivation effect. So it is very important then to actually dry surfaces to make sure that that doesn't occur. Now, having said that, in all the farms that I have visited, I very seldom see anybody waiting till surfaces are dry before applying the disinfectant. So what can we do? Well, there's a couple of things. One, if we're using a detergent product that by itself has some measure of biocidal activity, that would help the cause. In other words, when you're applying the detergent soak, you're reducing the logarithm of organisms by the phenomena that we talked about before, but also you're actually reducing the number of organisms by direct biocidal activity because the detergent itself has some biocidal activity. The second thing that can be done to mitigate the potential effect of dilution of pooled water is to use a disinfectant that has a lot of reserved biocidal power. In other words, if we're using disinfectants that are at the edge of efficacy performance, they will have little tolerance to things like dilution by a standing pool of water. But if we use a disinfectant that has a lot of power as demonstrated by a short contact time of activity, then intuitively you can think that there is a lot of more reserved biocidal power in that disinfectant. And that would help mitigate the potential effects of dilution by standing water.